All right, guys, so the second video here, I'm going to help you with the parallel circuit, and it's similar, but of course, parallel and series is a little bit different. One of the big differences to start off with is how do we calculate the equivalent resistance? You'll notice that we have this inverse relationship. And what that means is if I add more resistors in parallel, because I'm adding more and more branches or paths for circuits or for current to flow through, the total resistance of the circuit actually goes down. This is one of the reasons why if you turn too many things on in the bathroom or the kitchen, you blow a fuse or you trip the circuit breaker, because every time you add something to a circuit in parallel, the total current goes up because the total resistance goes down. So we could make a safety mechanism like a fuse blow or a circuit break to keep that current from getting too high and the wiring from getting too hot and starting in a fire. So we'll start with that. We're going to find the total resistance of the parallel circuit. So here it is. I've already done it. First of all, we're using the same parts to build the circuit. 4.5 volts from the batteries, 2 ohms, 4 ohms, 3 ohm resistors. Here's an appropriate picture of them showing them wired in parallel. Here's the calculation to find the equivalent resistance. Last time we just added them up, and the more you put in series, the higher the resistance. This time we add the inverses. So it's 1 over 2 plus 1 over 4 plus 1 over 3. So I do the fractions, right? The common denominator of 2, 4, and 3 is 12. So 1/2 is 6/12. 1/4 is 3/12. 1/3 is 4/12. So then I get 13/12. Now this is where a lot of students would stop and make a mistake. What we solve for is not the resistance. What we solved for is 1 over the resistance. So it simplifies to this. So if I want Req by itself, and I do, then I'm going to flip it, right? Take the reciprocal. So Req is 12 over 13, and if I put that as a decimal, that's 0.92 ohms. So interesting to a nerd like me, when we put these in series, remember it had 9 ohms of resistance. We take the same exact resistors and we put them in parallel, it's 0.9. It's 10 times less. So we expect somewhere in this circuit to have a current that might be 10 times greater, close to it. So that's our first step, find the resistance, right? And that's how we would do it. Let's go back and look at the next step. The next step says here for current, it says, unlike series circuit where there's only one path to flow, a parallel circuit, there are multiple paths. So the total current has to equal the current through all the resistors. And also the potential difference is going to be important as well, or the voltage. And we're going to use Kirchhoff's junction or loop law and junction law for both of those. So let's go ahead and start that. The next step I would do is I'd find the voltage drop across each one of those. It's going to be so easy, right? Remember, there's actually, in this case, there's 3 separate loops. Here's one loop. Battery raises charge 4.5 volts. That means it has to fall 4.5 in this loop. Same thing with the second loop. Raises charge across the 4 ohm resistor, it has to fall 4.5. And the same thing is true across the 3 ohm resistor. It has to fall 4.5 volts of potential. So for parallel circuits, calculating the voltage drop is simple. I'm going to write it this way. V across 2 ohms is equal to V across 3 ohms. It's equal to V across the 4 ohms. It's equal to V across the battery in magnitude anyways, and that's 4.5 volts. No calculations needed, just an understanding of Kirchhoff's loop law. What we will need to use to calculate is the current this time. So let's go ahead and do it. How do we find the current through this branch? Remember, there's going to be some large amount of current going through here, but here's a junction. Some's going to flow through the 2 ohm resistors, some's going to go to the junction of the 4 and the 3. So let's find the current through the 2 ohm first. Ohm's law looks like this. I through the 2 ohm resistor, Ohm's law for current is V over R. So the V across all of them is 4.5 volts. The R is 2. So what is that going to be? 1 1/4 early on the morning. Feel free to use your calculator. 2 1/4. 2.25 amps, right? Let's find the current through the 3 ohm. Again, 4.5 volts across a 3 ohm resistor. 4.5 divided by 3, 1.5. 1.5 amps. And finally, we'll do it across the 4 ohm. 4.5 volts across 4 ohms of resistance. Ooh, that's going to be 1 1/4, right? 4.5 divided by 4, 1 1/8. 1.13, I'll round it to. All right, so what we're saying then is if we add up all of this current, it should be the total current in the circuit. So what's that going to be? Let's just add it up here. Put a 0 there. 827. Why am I stalling out here? 278. 2,4. So I'm expecting a current of about 4.88 amps. Let's just apply Ohm's law to the total circuit. The total circuit has a voltage of 4.5 volts. The equivalent resistance of it is 0.92 amps. So let's see what comes out there. 92 ohms. I think I said amps. Going too quickly. 4.5 divided by 0.92. Look at that. 4.89 amps. So those two numbers are really close to matching up, and that should make sense. After almost 4.9 amps, and this goes through here, each one has a separate value, and that's what we calculated. And then after they come through their junctions here, it would be 4.9 again. All right, so do this. I've done it for you. Do this, and then tomorrow I'm going to give you simple circuits just like this. I'm going to ask you to show me that you can do these. All right, good luck, guys, and remember, got office hours if you need help.